Our next session, we lost one of the speakers at the last minute. David Rose from the MIT Media Lab couldn't make it. So I'm just going to ask Marius Swoboda to come on up. Marius has been with Rolls-Royce for 25 years. He's the company's head of physical, computational, and design sciences. And what that means, as he's going to explain, is that he figures out how to design incredibly complex objects using virtual reality. And that's what he's going to talk about. Take it away.
Thanks, Gideon, for your kind introduction. Good morning, everybody. My title of my talk is Virtual Reality at Rolls-Royce Deutschland, Ready for Takeoff. Before I start, I have to, especially in that audience, I have to clarify something. We are in Dubai and there are a lot of nice cars outside. Ferraris, Porsches, and so on. So a question to the audience, who came with a Rolls-Royce to the conference? Oh, nobody. That's interesting. Who came with an airplane to the conference? I think a lot of you. So when somebody of you came with an airplane to the conference, the chance is very big that you came with a Rolls-Royce engine. So that's what I wanted to clarify. I have nothing to do with automotive. I am aerospace engineer, aerodynamist, building engine, building very, very complicated machines. And I will talk today about how we have introduced virtual reality to visualize almost everything. What is shown here is a project in which we have developed that technology. What you see there is a stylized engine. On the left-hand side, the compressor, in the middle, the combustor, on the right-hand side, the turbine. And all the boxes there, don't read the boxes, but all the boxes are a distinct project which we have realized with our partner University of Cottbus. And as you see here, this project is called VIT, which stands for Virtual Turbomachinery. And this is already the third project here. We started with those VIT projects 2003. And if I think about today, about the hype around the word digital, I would call that project DIT, Digital Turbomachinery. But this is virtual or digital, it's the same. So that is mainly, we have looked how designers are designing engines. At that time, very manually. We tried to automate that and to do optimization around the processes which they did. 2010, when we introduced the third of those VIT projects, we thought that we have produced that much data, so much data, that we couldn't see the wood because of that much trees around. So we looked to a technology how to visualize what we did there. These are some of the results which we have produced. And here in that project, we thought that virtual turbomachinery needs virtual reality. So we set up a project where we implemented a virtual reality system. What is the problem in visualization? You know, our company has brilliant engineers, and these engineers have almost every day brilliant ideas. So that engineer is thinking about a very nice car, which is a Ferrari, which is a brilliant idea. Then he is going to a designer and he's explaining him his idea. And what then comes out is a Gogomobile. So that means that it is very difficult to communicate and to imagine in 3D. And we as a company, we are building the most complex machines, and therefore we need the best visualization techniques. I was often then asked by my seniors, just try to explain me in kind of scientific way, why do we need 3D visualization? Why 2D is not enough? And there is not much in the literature, but there is a work which is dated to 1996, so quite old, where those scientists showed the probants things like that on the right-hand side, and they asked them just to follow the vortices. And what came out, what you see here, is the error rate which the probants made versus the number of details which they have seen. Number of details is all those vertices. And that was the results in 2D. That was the results in 2D with kind of perspective. That was then the results with perspective and with tracking. Tracking means that you are, when you move your head, the object is changing. And this is the results with 3D perspective with tracking. And that, what does that mean? If you imagine you are looking to 100 details. You are looking to a scene like I'm looking to you, and if I like to see 100 details, my error rate is about 40% if I do it just in 2D. If I then proceed to 3D perspective and tracking, my error rate drops to 10%. So I see 90 details out of the 100. In 2D, I see just 60 out of the 100. And that was something which gave, let's say, my seniors the confidence that we need that technology. So we then start, what you see here, it's a really wordy slide. I will not go through all the details. When people are talking today about virtual reality, they are mostly talking about head-mounted displays on the left. And what you see here are the advantages and disadvantages of both technologies. The main advantage of head-mounted display is they are cheap, versus a cave is very expensive. The biggest disadvantage of head-mounted display is that you are fully immersive, so you cannot collaborate with people. You are just by yourself in virtual reality. So when we then started with that project 2010, and we had to do kind of a show to showcase that technology. So we started at the university. That is a two-sided cave, which was then extended to a wall, to a floor projection, as you can see here. Then we've been on a lot of different events. What you see here, that's me and the Ministry of Economy of Germany at that time, Mrs. Zypries. Then we had 2006 the opening ceremony. This is our CEO who has cut it, as you can see there, who has cut it a virtual band with a virtual knife. And then we have then opened the facility, which is shown on the upper right. This is more in detail. So it's what you can see here are three large displays, backlighted displays, plus two projectors which are projecting pictures to the floor. We have by intention opened that facility. So usually caves are rectangular. We have opened that so that more people can collaborate there. We have an infrared tracking system, which is tracking then the movement of your head. Four very powerful workstations which are steering the whole facility. And the facility is used as an open platform for really interdisciplinary communication. These are some pictures which shows you some of the applications and how big the facility is. We wanted, of course, to offer that facility to many departments, and it is, of course, not possible to get the department to work with it when you have to switch on 17 switches. So what we have then created is a small a mobile phone app which switches the whole facility and which is then loading the special application, like it is shown here. You see, this guy is walking through that facility, and the scene is always changing according to his position. Some use case categories. We have currently 4 use case categories. This is, for example, the digital mock-up, which is shown here. So the whole content which is shown here is, of course, is coming from our CAD system. So now, so the content is always there. We don't we don't need to prepare the content in a special way just to view it here. So this guy is now walking through that scene and is disassembling the engine, which contains, by the way, of 20,000 parts. The next use case category is factory layout. I don't like this one because that facility was not created for that. But at that time we have installed the facility, our factory or our assembly halls were created so that the content is also in CAD systems, and the people who are working in that facility, they were in the cave and tried to furbish the facility like in the reality. So you see, these are all the engine stands where the engines are built or are assembled. And this is now a kind of manager view when you are flying over the workers. Okay, and the next use category is a kind of learning category, assembly sequences. So what is shown here are the assembly of a so-called power gearbox, which was done for the first time in the Rolls-Royce Deutschland. And that was created by the engineers to show the workers how to assemble a part. So these are a lot of steps in the assembly procedure, and what you see now is how the parts are being assembled together. Okay, and finally, the next use category, I'm an aerodynamist, and my background is CFD, computational fluid dynamics, and this is why the cave was created, but we are still not there. And the problem is why we are not there is the computational power which you need to create such a visualization. So what you see here is the flow within the combustion chamber. Blue is cold, red is hot, like it should be. But in that case, the red colors that are around 2000 degrees Celsius, the blue color is around 700 degrees Celsius. And this is a so-called steady calculation, so you see just one time step of the whole calculation. And we are working, so in the future we will work on do this visualization in an unsteady manner. The other engine externals, the complexity, when we when people are talking about very complex stuff, very complicated things, they used to talk about rocket science. I don't understand that, because a rocket engine, for example, is very simple. It doesn't have even moving parts. The only moving parts in the rocket engines is the fuel pump, but that fuel pump lives for 5 to 6 minutes. That's it. An engine, this one here, the life cycle of that engine could be 30 to 40 years. And it is flying about 12 hours a day. And this is the turbo machinery. This is what is creating thrust. So what you see is the fan. What you usually see if you are entering the aircraft, compressor, combustor, and the turbine in the back. But what else is needed to make this device to fly can be shown here. So we can, what you see here are these are the distinct systems, like air system, oil system, cooling system, and so on. And then you can assemble that engine with all these parts. This is, for example, the electrical system, the injection system, oil system, all these green pipes. This is the air which is then going into the airplane, and so on and so on. And at the end, you have the full engine with all these 20,000 parts. The other cases, we call them the lay-down cases. This environment in such a virtual reality area is such that almost everybody is going to his knees. So these are our seniors, which are looking, which are lying down and looking to different parts of the engine. Okay, some chances. So we see this environment as a very good means of interdisciplinary communication. So people are talking about their parts in that facility, and this facility is also creating very much ideas. So. The other one is collaboration across sites, which you can see on the left-hand side is a guy working in a cave. On the right-hand side, this is the same guy somewhere else in the world as the avatar. So, talking about different things, about different details across the world. The other one, of course, training, because you can get people in there and you can show them in a virtual way how a part is assembled, and also of understanding of very complex systems. So Gideon mentioned that I'm working for Rolls-Royce more than 20 years, and I've learned in the last years a lot due to this environment. Challenges which we have, of course, company IT requirements. You can imagine that we don't want, as a visualization team, we don't want to give our IT department the control of our IT stuff. But the IT, of course, wants it. So this is very complicated. Also simulation of data visualization. Haptic response, you know, the people are in that environment, they always want to touch something and want to have some haptic response, and they are things which can be used. For example, we started to use very cheap Wii controllers, and when you're entering a zone which is not allowed to enter, the Wii controller is vibrating. And the last one, we would like to use that facility in the whole product life cycle, so in a whole technology readiness level cycle towards digital twin, for example. Okay, so that was from my side. My last slide is a riddle. Do you know what it is? Can you imagine what that is? These are not the Blumen Group. These are workers who are carrying the glass windows into the cave. Thanks a lot.
Thank you very much, Marius. So, I have a question. This is really cool, obviously. But people were designing aircraft pretty successfully for several decades before you built the cave.
Yeah.
And designing aircraft engines which managed to fly without crashing. So what is it really enabling you to do now that you couldn't do before, or how has it improved what are the concrete achievements or improvements on the process?
Well, I would say engines are getting more and more complex, and the reason for that is that we need to be more efficient, of course. If you look to the 737, Boeing 737 is dated, or the first one was built of 1957. So it's more than 60 years old. And now we have a disaster with 737 MAX.
Right.
And that is because the engines are more efficient, they are bigger, and the 737 as an aircraft stays the same.
But actually, that's an interesting example, because what went wrong with the 737 MAX is not the engines, right? It's the control system.
No, it is the engine.
It is
because
the engine.
Engine is getting bigger and bigger and bigger. And if you compare A320, for example, to the 737, the A320 is much higher as an aircraft because it's younger. It is prepared for those big engines.
Okay. Well, so what do you think will be possible 5 or 10 years from now that is not possible now in terms of this kind of virtual environment?
The people who are building that devices do understand much better what they are doing. In terms of multidisciplinarity. You have those people in the companies which are only do aerodynamics or which are only doing vibrations, and now they can combine all the disciplines together and understand the disciplines better, or understand the disciplines from their counterparts much better.
Okay, good. So what are some other sectors in which you think AR or VR is being used in interesting ways in industry sectors?
Well, what I mentioned before, for example, AR, augmented reality, for the digital twin, or for the real engine. You know, when you're comparing the design with your reality. So there are two digital twins. In fact, there's the first digital twin is as manufactured, and the second digital twin is as in service. So when the engine was flying for, I don't know, a few years, and then you can compare it to the real intent.
So what, you would be standing in front of the physical engine and also seeing the virtual one and comparing the two side by side.
How it behaves in a reality. For example, when the engines are flying in, let's say, Hawaii, in a salty air.
Right.
They are behaving much different than when they are flying in Dubai, in sandy air, let's say.
Right. And are there other, I mean, aside from engine design, do you think there are other applications that are potentially particularly fruitful?
As I have shown, for example, the assembly sequences and the furniture of this whole, which I don't like personally as a application, but they are being done.
Right. How does the spread of 5G technology affect this?
Especially in the assembly line. There will be the first application, I think, of 5G.
Which will be?
Just to know where are your parts.
I see.
Yeah.
Because you tag everything and then everything.
Because you tag everything, because you probably use Internet of Things to have small chips in every of your parts. Right. We are working with tagging already, but we would like to have really IoTs in every part.
Right, and then you could have a virtual representation of the factory, where you can find everything. You know where it is. You can figure out where it's gone to. Are there any other? I mean, I could call 5G like a helper technology for virtual reality in that sense, because it enables uses of it that you wouldn't have had before. Are there any other helper technologies?
Well, another application is when I think about visualization of simulation data. The simulations which we are doing, especially CFD simulations, are being done on big clusters somewhere else, and they are causing terabytes of data.
Yeah.
And we don't need to have all the data in the cave to visualize it. We just need the let's say the streamlines which are extracted out of the data, and these streamlines have to be converted somehow into the cave, and that is probably possible also with 5G in the future.
Okay, that's very useful. One other thing that is interesting. So you've been talking here about using VR for designing physical objects, which are very complicated. But a lot of the times, the most complex systems are not necessarily physical. I mean, they're communication network. I mean, they're physical, but they're not in the same way as an engine. It's communication networks, it's information networks, it's software structures.
Yes.
Is there a potential for VR to help us visualize something that was not previously visualized and plan it better?
No.
Go on, why not?
No, but it really helps to understand what we are doing in multidisciplinary way.
I mean, can you give an example of that?
For example, if you look at on the whole of the outside of the engine, the complicated stuff which I have shown. Today we are bringing several departments into the cave, and they are designing all these wiring together. So even if they are not from the same department, so oil department, for example, and the electrical department, the most happiest department is the first one who can do the beginning, and then the others they
have to work around.
Yes, and today we really see that that the engine from outside, that all the wirings is, let's say, it's looking better. It's not that kind of mess like it was before.
Right. So it's more efficient.
Yes.
Probably lighter.
Also, yes.
Good. People love to trash talk VR, and they say VR never found its killer app. Do you think that's true?
Not at all. Otherwise, I would not do this technology.
Is it more still, do you think, something that has industrial uses rather than consumer uses? Or do you think that there's going to be a big, important consumer use of VR?
Well, when you think about what Microsoft is doing with HoloLens, this is also kind of VR, AR, XR, they call it. If this technology would be qualitatively much better than it is today, that would also make this kind of devices obsolete.
Right.
But it's not. It's when you are there, you feel like you are in the object, and with the HoloLens, it's still you have the field is smaller, and the technology is not there simply.
Right. Do you have any sense of how long it will take before it is there?
You should ask these guys, which are sponsors here.
We'll ask them later. Okay, Marius Swoboda, thank you very, very much.
Thank you.
Now we have a coffee break.